About a year ago, I made a video about AI computer vision software called Deepstack that massively increases security camera motion detection accuracy. Since then, Blue Iris, the software-based NVR from that video, has gotten some major improvements. So today on the Hookup, I'm going to do a complete walkthrough for getting set up with Blue Iris and Deepstack for the most powerful, customizable, and expandable security camera system possible. Just so I don't waste anybody's time, Blue Iris is an NVR software that runs on Windows. This tutorial will be for getting Blue Iris and Deepstack running on Windows. Other installs do exist, like Windows virtual machines and Docker containers, but I haven't tried them, so you should probably expect things to work a little bit differently than they do here. If you're going to build your own Blue Iris machine from scratch, there are a few key things that you'll want to focus on, and thanks to today's video sponsor Govee, I was able to pick up 2 systems in the $300 range to test out. Govee's RGB IC strips are the easiest and most cost-effective way to get set up with individually addressable LED strips. In the box is everything you need to get set up and going, including a power supply, Bluetooth and Wi-Fi controller, mounting hardware, and even an alcohol wipe for prepping the surfaces. The Govee app lets you customize your strip in hundreds of different ways, including music reactive modes, preset scenes, and DIY selections. You can also voice control them via Amazon Echo and Google Home. Check out Govee's RGB IC strips and their Mother's Day promotion using the link down in the description. The first hardware setup that I tested is very similar to what I use in my personal setup. On eBay, I picked up a used Dell Optiplex with a 6th generation i7 processor, a 250GB solid-state hard drive, 8 gigs of RAM, and Windows 10 Pro pre-installed. I got all that for $269 plus $20 shipping, and I added a 2TB surveillance-grade hard drive for $70, which brought the total cost to around $360. One super annoying thing about these Dells is that they only come with a single standard SATA power cable. So if you want 2 hard drives, you're going to need to split that existing cable. The correct way to do that is with a purpose-built splitter, but I didn't have one on hand, so I just cut the existing wires and spliced in a 2-connector cable. I also had to get a little bit creative with the drive placement, but overall I think it turned out okay, aside from my terrible cable management. When you're shopping around on eBay or Facebook Marketplace, a 6th generation is about the oldest processor you should consider for Blue Iris, because that's when Intel added H.265 hardware decoding, which is basically becoming a requirement when it comes to high-resolution cameras. Second, to try to address some of the concerns that I've seen about power usage of an always-on PC, I picked up a 7th generation Celeron processor mini PC from Ace PC. For $199, it's got 6 gigs of RAM and a 120GB solid-state main hard drive. I installed a 2TB drive into the built-in expansion slot for a total of $270. When running Blue Iris and Deepstack, the mini PC's low-power Celeron chip used an average of 27 watts. This means running 24 hours a day, 365 days a year, it would consume 236.52 kilowatt hours, and in Florida we pay around 6 cents per kilowatt hour, which means this computer would cost $14.19 to run per year. This is pretty similar to a standalone NVR from Reolink, which draws only 20 watts when using non-PoE cameras. In contrast, the Dell used an average of 75 watts running Blue Iris and Deepstack, which would be 657 kilowatt hours a year, or $39.42, which is $25 more than the mini PC. But the question is it worth it? I'd say it really depends on your number of cameras, their resolution, and any other services that you want to run. But based on my testing, I wouldn't recommend the Celeron system for anything over 4 cameras, and probably not at all for 4K resolution cameras. Also, because it's a Celeron processor, it tries to stay in a low power state and it only turns on its turbo mode when needed. Unfortunately, this results in the processor being pegged at 100% most of the time. So unless your camera needs are really low, I really don't think I can recommend running Blue Iris on one of these mini PCs. If you've got a PC already and you're trying to squeeze out a little bit of extra performance, there are a bunch of Windows de-bloating tools out there that are worth checking out. Unfortunately, even those weren't enough to get the mini PC running up to my expectations. That being said, since my last video, Blue Iris has come an extremely long way as far as resource management, and with features like hardware decoding and substream switching, the Dell system was able to run 11 5 to 8 megapixel cameras with 24/7 substream recording, high-resolution motion recording, AI person detection, and live monitoring, all while keeping an average CPU usage of around 15%, with spikes up to around 50% during heavy motion analysis, which of course leaves plenty of headroom to run other services like Home Assistant and Plex. In order to achieve results like this, proper setup is everything, so let's jump into that. After getting through the initial Windows setup, I recommend spending a little bit of time letting Windows updates download and install. After that, you're going to download and install Blue Iris, which costs $69 for a license. The Blue Iris license is good forever, but it also comes with a year of support and feature updates. If you'd like to continue getting feature updates after your first year, then each additional year is $30. But your Blue Iris system will not stop working if you don't purchase that $30 per year extension. Quick note, if you enjoy my videos and you want to support my channel, I do have a Blue Iris affiliate link down in the description where I can earn a small commission of the sale at no cost to you. Alright, after installing, hold off on opening Blue Iris because we still need to install Deepstack, which is free and open source. The Deepstack website is a little bit confusing and it doesn't always take you to the right location to download the latest files. So I've got a link to the page that you need down in the description. On this page, you can choose between the Windows CPU or Windows GPU versions. For both setups in this video, I'm using the CPU version and that works great. Go ahead and set it up with the default location for the install, or at least remember where you installed it because you're going to need to know that later on. Now, you're ready to start Blue Iris, which will open up in demo mode until you enter a valid license key, which should have been delivered to your email. For completeness, I'm going to run through each menu and show you the important options to consider and what I use for them. But remember that all these options are here for a reason and your specific use case might require something different. If there was one best configuration, you wouldn't need any options at all. First, in the About tab, I keep automatic updates off. You'll still be notified when new updates are available, but keeping this setting off lets you choose when to update. Next, in Clips and Archiving, we're going to get our surveillance hard drive set up. Start by creating 4 folders on that drive. You can name them whatever you want, but I suggest DB, New, Stored, and Alerts. These are the folders where your Blue Iris footage is going to be stored. New is the folder where Blue Iris will initially store your footage, so you should allocate quite a bit of space to it. I set mine for 1,000 gigabytes and I don't limit the clip age. It just stores 1 terabyte of clips and then you can choose what to do after that. I personally just delete the oldest files, but you can also set them to transfer to a different folder for archiving. And that's where the stored folder comes in. If you have a large NAS or external drive, you could transfer your old footage onto it by putting your storage folder on that drive. Your new folder needs to be on a fast, local storage drive, but this one can pretty much be wherever you want. Since I have my new folder set to delete old footage when it reaches 1 terabyte, I just use the storage folder for exported clips, and as a result, it doesn't need to be large. I limit my folder to 20 gigabytes and I set it to delete when that space is gone. The Alerts folder will mostly be used for debugging and occasional Home Assistant use. Even though Deepstack will generate entries in the Alerts tab, by default, those clips will just be in your new folder. The only thing that should end up in your Alerts folder are high-resolution JPEG files containing the results of the Deepstack analysis. I set this folder to 1 gigabyte max and I limit the age of the clips to 7 days. Also, don't forget to change the location of the database file to the DB folder before moving on to the Users tab. Blue Iris's user menu is extremely powerful and it offers everything that a cybersecurity conscious person could want. You can create users without administrator privileges, restrict logins to the local network only, limit the time of day that specific users can log in, and you can limit the camera groups that each user has access to. You can even set up custom alerts like notifications of specific users logging in and logging out. As a home user, my setup doesn't utilize any of that fancy stuff, and instead I just create a new profile with a secure password. I give that profile admin privileges, and since I only access my Blue Iris via VPN, I can restrict that access to LAN only. If you're going to set up remote access via port forwarding, you shouldn't check the LAN only box. After creating that new user, I disable all the other default user profiles, which is best practice for any hardware or software. The web server tab is next, and it's one of Blue Iris's best features. The UI3 interface is my favorite way to interact with Blue Iris because it's simple and responsive and it runs on almost any computer. Start by enabling the web server, which defaults to port 81, and make sure to select the box to use the UI3 interface. The local LAN IP should just auto-populate. Next is remote access, which could be a whole video on its own, so I'm not really going to go into any specifics. I use Blue Iris with my Unified VLAN, which means I don't need to set up remote viewing at all, since VLAN traffic just acts like local network traffic. If you want to set up remote access, I'd recommend using the excellent Remote Access Wizard. In the startup section, the only really important setting is to make sure that Blue Iris runs as a service. Not only does this reduce resource usage because you don't need to run the UI, but it also means that when your computer restarts, Blue Iris will start up even if you don't log into Windows. This is also going to be really important for getting Deepstack started after a restart. Other profiles, joystick, keyboard shortcuts, macro, and audio don't really have any settings that need to be changed, so next jump over to the cameras section. In this section, you'll select your default hardware acceleration profile. This is what I was talking about when I said that a 6th generation Intel processor is the best option. In almost all cases, you want to select Intel plus VPP, which means that when you select the default encoding profile during camera setup later on, it'll use Intel's QuickSync video decoding instead of raw processing power. Next is the AI tab, where we'll initially set up Deepstack. You can basically keep all the initial settings. The IP address for the Deepstack server is listed as 127.0.0.1, which is localhost, and that just means that it's located on this computer. If you change the install directory, you need to specify that here, and then you can choose how thoroughly you want Deepstack to analyze each image. I've had some pretty good luck with medium, but if you need something a little bit more accurate and you have the processing power to spare, you can bump it up to high. After that, you can start up Deepstack by pressing the start button. And this should be the only time that you need to do that, because you're also going to check the box to start Deepstack anytime Blue Iris starts. I'd keep facial detection off for now, and I may do a whole video on it later on, but it's not really ready for prime time yet. The only other tabs that I mess around with are the mobile devices tab, which is where you set up your cameras to use with Amazon Echo devices, and the IoT tab, where you can set up your MQTT server to work with your home automation platform. But both of those are going to be beyond the scope of this already long video. Using Blue Iris as intended, we can set up a single camera to continuously record the low resolution stream while switching to high resolution for any motion events. Those motion events are then run through Deepstack AI computer vision, and alerts are generated for positive AI detections. This option was released less than a week ago, and it's easy to set up, intuitive to use, and will probably improve significantly with every new release. But right now, it has a few problems. Specifically, there are 4 things that I'm not thrilled with. First, it switches to high resolution recording for all motion events, not just positive AI detections. And this means your hard drive space is going to fill up faster with non-relevant events recorded in 4K. Second, it doesn't seem to honor the setting for pre-trigger video buffer, meaning when I watch my motion clips, the first small part of each detection is in low resolution before it switches over to high resolution. Third, exporting these hybrid clips is hit and miss. If the mainstream and substream are not perfectly in sync, you can miss whole parts of a motion event. And I'm guessing that that's directly related to my 4th issue, which is that it just plain doesn't work with some cameras like the Reolink RLC-810A. Most likely because the iframe interval is too low for it to properly sync up the main and substreams on such short notice. As I said, this option is less than a week old, so most of these issues are probably going to be fixed soon. However, if you try out this traditional setup and it isn't quite working for you with your cameras or your hardware, I'll post a link to an article on my website where I show some of the alternate settings that I'm currently using to work around some of these problems, including the dual stream recording incompatibility with the Reolink RLC-810A. The reason that I'm not showing them in the video is that I'm hoping that these settings are going to quickly go out of date with the Blue Iris developers pushing out so many updates and fixes. Either way, we need to get started by adding our cameras to Blue Iris via ONVIF. Right-click on the main screen of Blue Iris and select Add New Camera. I prefer the full name and short name to be the same, but it's really up to you. Select Network IP as the camera type and enable motion detector and direct-to-disk recording. The first window you'll see is the video stream configuration. Blue Iris has come a long way in detecting and auto-populating stream information via ONVIF, given the camera's IP address, username, and password. And it does a great job detecting things like mainstream and substream, and even sets up things like PTZ presets and audio channels. But my Hikvision camera doesn't come back with any information. This actually turns out not to be Blue Iris's fault, and by default, ONVIF on Hikvision cameras is disabled and requires you to go in and specifically set up an ONVIF user via the camera's web interface. Enki, which is a Hikvision OEM, is the exact same way. You want to make sure that you have a mainstream and substream selected for each camera, because using dual streams will drastically decrease the CPU usage when you have a bunch of high-resolution cameras. Reolink cameras behave the worst in this case, and I think most of the issues that people report to me are because they just type in the IP address here, which doesn't properly populate those correct streams. These are the Reolink RTSP streams for their non-4K cameras, and these are the ones for their 4K cameras. Note that the mainstream is H.265 and the substream is H.264. I also get the best performance out of my Reolink RLC-810A when I have my mainstream and substream set to these settings within the camera interface. Matching the mainstream and substream frames per second seems to give the best performance, and I also check the box for the decoder compatibility mode. Not directly related to this video, but I've also had really good luck getting rid of the nighttime smearing issues using these image settings on my Reolink RLC-810A. After that, in the video tab, you want to select a max frame rate that is the same or slightly greater than the frames per second that you have set up on each camera. Blue Iris uses this to set aside RAM, so setting this too high can cause unnecessary RAM usage. I have all of my cameras set to 15 frames per second, except for my driveway camera that's set to 25, but your preferences may be different. For hardware decoding, since you selected Intel plus VPP earlier in the global settings, you can just leave this on default. I let my cameras handle the time and date overlays, so I also uncheck the Display Overlays Live button, which also helps saving processor usage. Starting the General tab, you want to create a group for your cameras. This will control how you view multiple cameras and how you would restrict access to a specific user to only a few cameras. I'm just going to put them all into a group called Main. There's not much to change in the Audio tab, and if you used ONVIF Discovery, everything should just be auto-populated. The Trigger tab is probably the most important. First, we're going to set up the motion sensor. Minimum object size refers to the dimensions in pixels for the smallest change in color and contrast to register as motion. I set my object size very small, just 250 pixels, and my contrast low, 25. Remember that we're going to ultimately use computer vision to analyze each event. So we just want to give Deepstack as many chances as we can to find a person, car, bear, or whatever we're looking for. I also keep my make time, which is the amount of time that object needs to be moving, at just half a second. I also select simple for the algorithm and I turn off object detection. Just to be clear, these are terrible motion detection settings without Deepstack, but we're going to rely on computer vision to get the most accurate results. Down in the When Triggered section, you can choose between database only or high-res JPEG file in the drop-down menu. This is going to determine whether Deepstack uses a low-resolution image for computer vision or a high-res one. If you have 4K cameras and you notice Deepstack spiking your CPU or taking way too long to analyze your pictures, you might want to use database only. Next, click on the Artificial Intelligence section and select Deepstack. There are some auto-populated objects, but Deepstack can detect all of these things, so just add or remove them for your use case. Confidence level is exactly what it sounds like, how confident Deepstack is that the object in the image is what you're looking for. I found that 60% works well for me, but if you get too many false positives, you can raise it, and too many misses, you can lower it. I'll also show you how to debug this later on. Next, you want to give Deepstack as many chances to find your object as you can. So I set it to analyze 5 additional images, 1 per second after each motion event. For the rest of the options, I just use the default, except for I check Burn Label Markup onto alert images, and I also use the Auto Flag Confirmed Alerts because it makes the mobile app a little bit more functional. Amazingly, that's all you need to do to get Deepstack set up. Press OK and then set a 10-second break time, which records for 10 seconds after the trigger, and then it ends the clip if there's no more motion. If you notice that your recordings are ending before the motion leaves the frame, or if a single motion event is creating multiple clips, then increasing the break time is going to fix that. In the Record tab, you'll want to select the brand new option to record video continuously and when triggered. And even though I don't think it's currently working, you'll also want to add a pre-trigger buffer that's equal to or slightly greater than the number of additional seconds that you specified in your Deepstack settings. This setting continually stores some of the footage directly into RAM to save in the event that a motion trigger happens. This essentially allows Blue Iris to travel back in time and start recording earlier. Also, check the button to record dual streams if available. This means that each motion event will record in both low resolution and high resolution. It's not completely necessary since you're mostly going to be interested in the high resolution stream, but if you're watching synchronized multi-camera timeline playback, it makes things much smoother. You shouldn't have to change anything in the video file format and compression window since you selected direct to disk when you added the camera in the first place, but it's worth checking since direct to disk is the most important option for increased performance. Last is the Alerts tab, where you can select what motion events cause what actions. You can use push notifications in the mobile app, MQTT to your home automation server, text messages, email, and a ton of other stuff. You can also specify specific AI detection objects in your alerts, so you could record for people in cars but only send an alert on people, or record dogs, people in cars but skip the alert if there's a dog. This tab is super powerful, but it's largely going to depend on your use case. Thankfully, there's not much else to do in these other tabs, so you can just hit OK to load up your camera. Then, to add the rest of the cameras, you can just right-click, choose Add New Camera, and then clone that camera that you just made. In the Video tab, click Configure, and then enter your next camera's IP address, login, and password, and then you're done. So at this point, your cameras are all set up, but there were a lot of variables and settings, so it's time to make sure that you did everything right and your cameras are functioning as well as they can be. Go up to the top of Blue Iris and click on the status icon that looks like a line graph. The first tab that we want to look at is Cameras. Some of the important things to check are under HA, which stands for hardware acceleration. You should see either I or I+, meaning your cameras are using Intel QuickSync. If not, check your global setting and then your individual camera settings. Second, make sure you check out your megapixels. This is the resolution of your mainstream and then a slash and then the resolution of the substream. For the mainstream, just make sure that it's what you're expecting. And then for the substream, you want to make sure that in general they're less than 1 megapixel. For best performance, you want your frames per second to be the same on your mainstream and substream, and the Blue Iris developers recommend having a keyframe or iframe interval once every second. That means that if your camera allows for it, you should set your iframe interval to be equal to your frames per second. In Blue Iris, this is displayed as a ratio, so a 0.5 ratio would be a keyframe every 2 seconds. Unfortunately, this is another strike against Reolink cameras here, since they aren't able to adjust their iframe interval in their software, and they're set to 0.5 for the mainstream and 0.25 for the substream. Last, if you head over to the log tab, you can see how long each deep stack analysis is taking. I'd say you want to shoot for under 1 second each, but I did notice some occasional spikes over 1 second, especially when motion occurred in the area where multiple cameras can see. That Celeron processor we were talking about earlier often had times in the 3 to 4 second range, which just isn't going to cut it. You can try to fix this by reducing your deep stack level from medium to low, or in my actual server, I happen to have a GT 1030 graphics card that easily handles computer vision on the high setting in about half a second per process. But unfortunately, I know it's kind of impossible to buy any graphics card right now. Assuming you've got all your cameras set up now just the way you want them, you can now start tweaking the motion and AI settings to be perfect for your specific camera locations. To do this, you can browse through that alerts folder to see what Deepstack found and the confidence levels that it had. If you find an image that doesn't have anything detected, but it should, you can drag it into Blue Iris and then right-click on it and choose Analyze Image with Deepstack. The same can be done using the snapshot tool on the live view. Again, click Analyze Image with Deepstack. Another trick that you can use in the live view is to figure out why your motion analysis may be producing too many false positives or too many false negatives. If you're analyzing a clip, you can change the motion settings in the camera window, and then when you're watching that clip, you can hit Test Run Video through Motion Detector to see how your settings changes will affect the motion detection. Ultimately, the reason that Blue Iris is my NVR of choice is the fact that it is massively customizable. And much like Home Assistant, I rarely find myself saying, well, that's just not possible. If you're looking for more Blue Iris content, they've recently started doing webinars, which they're posting on their own YouTube channel, and they're definitely worth checking out. Thank you so much to my awesome patrons over at Patreon for your continued support of my channel. If you're interested in supporting my channel, please check out the links down in the description. If you enjoyed this video, please hit that thumbs up button and consider subscribing. And as always, thanks for watching The Hookup.